This example I find very interesting, albeit quite outside my area of expertise. But by analyzing word choice in written passages of text, we can identify the author. Sometimes, if they have similar word choice or the way that their writing is structured, then we can use it to determine authorship. And this example that we found analyzed Plato's Republic and found that 26.1% of 5-syllable sequences were in the particular type, where 2 were short and 3 of the syllables were long. So Greek archaeologists found another ancient manuscript dating back to around his time. We're curious to see if Plato wrote it. We can take a sample of 317 5-syllable sequences from this new manuscript and measure the percentage of this type of structure. They found that 61 of those 317 had the same type, where 2 short and 3 long syllables. We can use that to indicate or to test whether the sequence is different in the new manuscript, and to see if perhaps Plato could have been an author of this text. So, how do we analyze it statistically? First, we have to identify what we're testing, and we're definitely testing a proportion, right? We're testing a proportion. We assume Plato's structure, or the proportion of syllables in his prose, is 0.261, where 2 short and 3 long. We want to know if the sequence in the new manuscript is any different than 0.261. Therein is the null and alternative hypothesis. The level of significance is given to be 0.01. To calculate the test statistic, so now we just jumped right in and made the null and alternative hypotheses, we can make the test statistic by remembering the formula. If it's a proportion, it's definitely a z test statistic, p hat minus p divided by the square root of p times 1 minus p divided by n. Now we need some pieces here. What is p hat? P hat is the number in the sample that exhibited the characteristic divided by the sample size, and that's not given to us directly, the proportion from the sample, so we'll cook it up. 61 of the 317 5-syllable sequences gives us a sample proportion of 0.192429. And P, of course, is the null hypothesis, 0.261. And sample size n is 317. So we can cook up the value of this z test statistic. Z equals 0.192429 minus 0.261 divided by the square root of 0.261 times 1 minus 0.261 divided by 317. To make sure that we get this number as accurate as possible, we're going to keep as many decimal places as we can here for p hat or any other number that shows up to be a long decimal place. So don't get lazy, use the calculator to your advantage to get to minimize rounding error, which can cause a lot of frustration when you're messing with the online homework platforms that have a built-in tolerance. Remember, for the numerator, we'll need a set of parentheses that say, hey calculator, use all this stuff, and then make the division. So I'll open those parentheses up and then do 0.192429 minus 0.261 divided by the square root of 0.261 times 1 minus 0.261 divided by the sample size 317. Notice how in this calculator the square root goes all the way over all this stuff, and we want to make sure that even the 317 is under the radical. If you arrow over and then type again, you'll see that the radical sign is gone. It's not above the 317. That did not get included, and that's not what we want. In the formula, and the sample size is under the radical, we want to keep it there. If your radical doesn't keep going, you'll have another parenthesis on this side to say that you're ending the square root. I'm pressing enter. Make sure you've got it entered correctly. You'll get the same value for the test statistic for z, negative 2.779 or negative 2.78 to 2 decimal places. We choose 2 decimal places because the next thing to do is find what the p-value is. And it's a z distribution, so we can read this p-value from the table. Remember, this distribution of sample proportions is approximately normal. The test statistic we found was negative 2.78, so the p-value is the area to the left of negative 2.78. What's the probability that z is less than negative 2.78? And then because the the hypothesis test is two-tailed, we'll multiply this probability times 2. We want to also consider the possibility of it being on the other side. That's because the alternative hypothesis was two-tailed, or the test said test if it's different. So let's look up the table. Negative 2.78. 2.7, cross the column to 8, is 0.0027 for the p-value. And multiply that bad boy by 2, gives the p-value of 0.0054. So, level of significance, 0.01, p-value, 0.0054. There's p, alpha, 0.01. Is p less than alpha? That is the question. And that will help us make the decision. Is p less than alpha? Yes, p is less than alpha, therefore we can reject the null hypothesis. That means that there is sufficient data from this sample to support the alternative hypothesis, to reject the null hypothesis, to claim that the null hypothesis probably isn't the case, and that the alternative hypothesis is most likely true. So what does that mean here? If we say, did Plato write this or not? Well, it's probably not true for our null hypothesis, that the percentage of these syllable sequences to be 26.1%. So we can make a conclusion in interpretation to say that, yes, the data indicate that the proportion of 5-syllable sequences of this type is in fact different than that of Plato's Republic. So can we say that Plato didn't write this? No, we can't say that for sure. Maybe he did write it, but in a different style, or he used a different tone. So we can't be totally sure, but the data would lead us to believe that perhaps he did not.